Good morning, students. Now we will start with another topic, that is number of tangents from a point on a circle. Now draw a circle on a paper, okay, and take a point P inside the circle. Now can you draw any tangent through this point? Just see, when you draw if you draw infinite number of lines through this point, but you will find that it is not possible to draw any tangent to a circle, because whenever you draw a line you will find that the lines are intersecting the circle at 2 points. Okay, and we know that a tangent touches the circle at only one point. So it is not possible to draw any tangent to a circle passing through a point lying inside the circle. So when a line point is inside the circle, you cannot draw a tangent through that point. Okay. This is the first observation. Second, suppose that we take a circle, okay, and take a point P on the circle. Now draw tangents through this, or draw lines through this point. What will you find? That you will find that you can draw only one tangent to a circle at such point. Okay, so what do you observe? That there is only one and only one tangent to a circle passing through a point lying on the circle. Okay, now let us take third case. Let us take a point P which is lying outside the circle, and now try to draw tangents through this point. Okay, from this point, if you draw the tangents, what will you observe? That you can draw exactly two tangents through a point lying outside the circle. Okay, so these are the three observations, or these are the three facts. Now the length of the segment of the tangent from the external point P and the point of contact. So T1 and T2 are the points of contact and P is the external point. So these are called PT1 and PT2 are called the length of the tangent. Now let us prove the second theorem of this chapter. That is, there are only two theorems I told you. That the length of the tangents drawn from an external point to a circle are equal. Means if the lengths of the tangents, or the tangents which are drawn from the external point to the circle, are always equal. Okay, so let us prove it. Let us draw a circle with center O in which PA and PB are two tangents from an external point P to the circle. Okay, we have to prove that the lengths of the tangents from an external point are equal. Means we have to prove that PA equals to PB. For this we have done a construction: join OA, OB and OP. Now let us prove it in triangle PAO and triangle PBO. Angle OAP and angle OBP is equal to 90 degree. As we know that AP is a tangent at point P. So AP is a tangent, and similarly BP is a tangent. Okay, and we know that tangents and radius are perpendicular to each other. OP is equal to OP common. OA is equal to OB, both are radii of the circle. Therefore, the two triangles are congruent by RHS congruency rule. Since the two triangles are congruent, therefore PA equals to PB by CP/CT. Hence, proved. Now, since PA is equal to PB, angle APO, this angle will be equal to this angle BPO, CP/CT. So, tangents are equally inclined also. Okay, children. So, remember this. When tangents are equal, they are equally inclined also. Angle AOP, this angle, is equal to angle BOP again by CP/CT. So tangents subtend equal angles at the center also. So these are the three properties which you have to remember. That the lengths of the tangents drawn from an external point to a circle are equal. Number two, tangents are equally inclined, means this angle will be equal to this angle. and tangents obtain equal angles at the center, means this angle is also equal to this angle. Now let us start with exercise 10.2. Question number 1. From a point Q, the length of the tangent to a circle is 24 centimeter and the distance of Q from the center is 25 centimeter. Find the radius of the circle. So let us draw a circle. Let PQ be the tangent. So it is given PQ is 24 centimeter and the distance of Q from the center, means OQ, is 25 centimeter. We have to find out the radius of the circle. Now this is 90 degree. We know that radius and tangents are perpendicular to each other. So OP is perpendicular to PQ. So we'll use the Pythagoras theorem because it is a right angle triangle. When you use Pythagoras theorem, OP square is equal to OQ square minus PQ square. That is 25 square minus 24 square. That is equal to 49, or OP is equal to 7 centimeter. So option A is correct. Now come to question number 2. In figure 11, if TP and TQ are two tangents to a circle with center O such that angle POQ is equal to 110 degree, find angle PTQ. Now TP and TQ are two tangents. We have to find angle PTQ. So we have to find out this. Now we know that the radius to the tangents are perpendicular. So this angle is 90 degree. This is also 90 degree. Okay. This is 110. We know that the sum of the four angles of a quadrilateral is 360 degree. Three angles we are knowing. Can you find out angle PTQ? So that will be equal to 110 plus 90 plus 90. Okay, so you will subtract this three sums from 360 degree. You will get the answer as 70 degree. Okay. Now come to question number 3. If tangents PA and PB from a point P to a circle with center O are inclined to each other at angle 80 degree, then angle POA is equal to. So let us see. So here it is a circle with exterior point P. PA and PB are the two tangents. Okay, so this is PA and this is PB, and they are inclined to each other at an angle 80 degree. Then angle POA. So we have to find out this angle, this one. Okay, we have to find out this angle. And angle BPA is equal to 80 degree, this one. Now since PA and PB are the tangents, okay, so and therefore OA will be perpendicular to AP. Radius and tangents are perpendicular to each other. Similarly, OB is perpendicular to AB. So same thing you will be using here as the previous question, that this is 90, 90, this is 80. We have to find out, we will first find out this angle, isn't it? So here I have told you earlier also that these two angles are equal because they are equally inclined, and here also these two angles are equal. So even if you take either, you can take by taking the sum of all the four angles of the quadrilateral, and whatever answer comes you just divide by 2, or you can take individually any one triangle. Okay, so we have to find out angle POA. So I will take triangle POA. This will be 40 plus 90. Angle sum property, you subtract from 180. So 180 minus 40 plus 90 is 130. So your answer is 50 degree. So children, complete this questions in your copy. Thank you.